King. All right. Remember, I'm keeping track if you're struggling with getting ready with writing utensils, writing down in our notebook. I'll start listing people who need to practice in the back. Like, you know, it's time for you to know what you're supposed to do. And where we can get to be breathing correctly, focusing correctly, all of this getting us ready to learn and to be the best students that we can possibly be. So let's breathe. And picking one spot to focus on. Perfect. Understanding that mistakes are part of learning, and we will support each other in taking risks and learning from our errors. Inspiring character and belonging. Actually, that's a really good way to inspire belonging, is accepting people when they make a mistake. Right? Encouraging, supporting. Think about something that you're going to do today, or try to, and write that down in your notebook. It does not matter how slowly you go as long as you do not stop. So Confucius was a very famous ancient Chinese philosopher. This idea that it doesn't matter if we're slow about it, right, but we should be moving, we should be trying, and you shouldn't ever stop.
I know people are slower than others.
What's up?
I know people are slower than others.
Yeah, for sure. Some of us think slower, some of us are just, takes longer times to do stuff, and that's okay. But the idea is not to stop. Okay, we still want to be going. What are the 7 things every brain needs to thrive? Let's see, each person name one. Roger, name one. Sleep. Juan, Martin. Downtime. Carlton. Play. Go. What's up? Focus. Focus. Yes, man. Exercise. Martin. Marcos? What's that? Oh, that's that. Did you say downtime? Downtime. So that's that calm. So the other calm would be timing. And then what's the last one? Really important that we'll miss.
Which one?
The last one. No, it's super important. Time limit was kind of a calm one. There's one last one. No? Okay, everybody say sleep on the count of 3. 1, 2, 3.
No,
Sleep.
yeah.
You said sleep. You said sleep. So then we missed connection. So everybody say connection. 1, 2, 3. Connection. There it is. What are 3 activities we defined as play, Max? What are 3 things that I consider play?
Board games.
Uh-huh. Exploring,
sports.
right? Yeah. Not playing sports, but if you're like pretending you're someone as you're playing the sport, that would be fine. But if you're like in a physical game where you're trying to win, that would not be play.
Like video games like Minecraft.
Okay, so like a building one. All right, cool. What are 3 activities we define as downtime? Okay, Alicia, what are 3 things that we defined as downtime? Wait, just being silent, yeah? What's another one? Yeah, looking at the clouds, it's the second one. What's that? Doodle! There it is. What are the 2 best ways to start a new habit, Lucia?
Habit stacking.
Uh-huh.
And I put that like starting like little by little.
Close. You have to be specific. You have to mention 2 things. Amelia, yeah.
Time and place.
Time and place, what was it? Time and place, good. What are your 4 summative grades? What are your 4 summative grades?
The big thing.
Which one?
Like the final one.
Okay, yeah.
I think so many things.
Mm-hmm.
And the test. I don't remember what it's
Okay, there's like a final unit assessment, and then there's also a mid-unit one. Which, I don't know if we're going to do that one or not. We'll see. All right, cool. Model. So model, we can say 2 different ways. So a model can be a noun, okay, person, place, or thing, and model can also be a verb. All right. Again, as you're looking down at your notebook, you won't see images. It's going to be much harder to get information into your brain. So a model is something that we use. Right? Okay, it's a physical thing, a representation for our phenomena. So it could be the box that we have. A model can be also something that was drawn. We tried that yesterday. Or the last time. We're getting there. I've mixed it up a little bit. Practice. We engage in the scientists to make sense of phenomena. So this is the verb. So model can be a verb. It's something that we can do. We can model things. Okay, trying to figure things out. And it's also a noun. So on Friday, we did... On Friday, on the last time we met with each other, you all tried to do this, okay? This model. And so I'm going to go over what it could have looked like so you can kind of reflect on maybe how you did when it came to doing this. So right off the bat, I think most of us realize that light is coming from the light source. It's reflecting off of our friend here. And then it starts to interact with the one-way mirror. But what can I do here? I can say this is going to be clear and transparent. And this, if I draw this in, it means shiny and reflective. So I am going to have pieces here. I'm going to add that to my model. That shows that it's shiny and reflective as well as transparent. Why would that be important to add to my model? I'm going to show what's going on. We always want our models to show what's happening. If I don't mention that this is a one-way mirror, that's going to be pretty hard for anyone looking at it to understand what's going on. So the light comes and reflects off that shiny part and goes into his eyes. There it is. That's all the light, right? Now, some of it goes, through the transparent and goes into the eyes of the teacher. I'm not doing a great job. This is kind of curved a little bit. I should try and make it as straight as possible. This is not all that's happening. I need to think about other things that could be happening. Light is coming from here, and then it kind of comes into here, and it actually bounces off the teacher a little bit, and does what? Okay, it probably comes back off, and then it also goes through, transmits, yeah.
But like he can't see.
Yeah, so that's tricky. It's tricky because there is some light reflecting off of the teacher, like there has to be, but for some reason, the student still can't see it. So that's going to be something we have to think about, like why might that be? Huh?
So maybe it bounces
Ah, it could be something with the glasses. That could be. She has glasses too, right? They probably thought of that. Is there anything else going on here that I would need to make sure that I showed? What's up? Right. Mm-hmm. Mm-hmm.
And he's like reflecting and bouncing off because it's much light.
Mm-hmm.
Yes.
Yeah.
And in the dark room, it's like some little light is not off, so like the student can only see himself and the teacher just that.
Could be. It could be. So we have to kind of.
If it would be like lighting both rooms,
Mm-hmm.
and like the teacher will be herself too. But
Right. Because then it would be. It would kind of. She would start seeing herself there. So I wonder. Why he doesn't see that light coming from her. We have to think about that. And we also have to think about why on earth, what kind of happens after light gets into our eye. So I think if we understand what happens to light when it gets into our eye, it's going to make sense of what's happening with the light as it travels around. So we're going to investigate that today. We're going to think about and learn about, we've learned about the parts of the eye, and now we're going to learn about what happens when light gets into our eye. How do we actually see? Okay, this magical thing that we're able to do. So your things to ponder today, how does light focus on our retina? So how does light get into our retina? How does it focus on there? What happens to light when it enters our eye? And what happens to light when it travels through transparent materials? So think about those things. I'll give you a moment to write some ideas down. We are going to watch a video. Unfortunately, my speaker doesn't really work with my computer, which is a shame, so I have to be very, very quiet. I'm strained to hear. But it can be worse. What do I do? With that?
in the video here, the video is going to answer a question.
Yeah. All right.
What was the last? Okay.
So Carlota shared an idea about why she thinks the student cannot see the teacher. Is there any other thoughts on what else might explain? We have two light sources coming into his eye, but he only sees one of them. So talk to your partner real quick. Have that quick conversation, 6-inch conversation. What do you think might be happening? What could be the problem? What's going on?
Porque uno más light source is powerful. Yo pienso en el salón del Señor hay demasiadas como las pequeñas.
Wait, 3, 2, 1, 0. All right, so this idea that there's not enough light, okay, coming back, but they're just not able to see it. Okay. Let's see. So set up your science notebook. At the top right, what happens to light after it enters the student's eye so that the student sees himself? We're going to learn, why does the student actually see himself? Okay, what happens to light when it gets into our eye? We're going to watch a video, so you're going to do some noticings and some wondering. So you need to, I'll give you 2 minutes to set up your notebook.
Can I do it in this page?
So again, write the question, what happens to light after it enters the student's eyes so that the student sees himself? And then create a noticing and wondering chart.
What happened?
I know, you need to copy that down. Copy the question, what happens to light after it enters the student's eyes so that the student sees himself, and then draw a 2-column notice and wonder chart.
Oh, so we don't answer the question.
No.
I go to a casa embrujada.
Another minute.
Y enseñas un loco que coge lo que dice por 5 horas. Espera.
All right, so again, we're going to watch a video. Again, my speakers don't work, so let me see. So you got to listen very, very. And I'll make sure the closed captions are there. Why is this not doing anything? But there should be something going on here. Ah, got it. So as we're watching this, make sure you write down some things that you notice and some things that you're wondering. So we'll watch this once, and then you'll have some more time to kind of write down some things that you notice, and again, and something that you're wondering.
Your eyes allow you to see the world around you, but have you ever wondered how they work? First, it's important to know that vision depends on your brain as much as on your eyes. Your eye's main job is to detect patterns of light. Then, they work with your brain to turn those patterns into images. Let's take a closer look. Light rays bounce off an object you are looking at. Let's say the object is a dog. The light reflects off the dog to your eye. Then, the light enters through the outer part of your eye, called the cornea. The cornea is clear like a window. It helps your eye focus the light to make things look sharp and clear. Next, the light rays pass through an opening called the pupil. The pupil is the dark round circle in the colored part of your eye. The colored part is called the iris. It controls how wide the pupil is and how much light can pass into your eye. In bright light, the iris narrows the pupil, reducing the amount of light that enters the eye. In dim light, the iris widens the pupil to let in more light. All of this happens automatically. Behind the iris is the lens of the eye. It helps focus the light coming into your eye so you can see things clearly. The lens flattens so you can see things that are far away, and bends so you can see things up close. When the lens, cornea, and pupil are all working together properly, they will focus light on the back of the eye. That's important because lining the back of the eye is the retina. There are about 130 million tiny cells in the retina that are sensitive to light. When these cells detect light, they turn it into electrical signals. Those signals eventually make their way through the optic nerve, which is like a cable connecting the retina to the brain. The retina helps create a rough image, but it sees the world upside down. It's your brain that turns what you see right side up. Also, when you look at an object, each eye gets a slightly different view of the world. The brain combines those views and makes them into one picture. The brain also adds a lot of details to your vision, so that you can see complex shapes, movement, depth, and a rainbow of colors. And of course, the brain connects your sense of sight to things you already know, so that when you see a dog, you recognize it as a dog, and not a cat or a monkey. And that's how you're able to see. To learn more about how your eyes work, visit nei.nih.gov.
Let's take another moment. Again, what did you notice? What are you wondering? You should at least be able to do at least 1, 2, maybe 3 noticing, at least 1 wondering. What did you see?
I would say that when we like the white part like do like this, like it's flat.
What's that?
Like how the white part
In the back?
yes,
Or that passes through?
that helps you like see things from far away.
Which part? Like it was the cornea, lens.
Yeah. Mr. Light.
Yeah.
So there's a part that we see, the part of our eyes is like upside down, and
Yeah.
the brain tells
Yeah.
it that is.
Yeah.
So if we didn't have a brain, we'd see upside down. Well, like
I mean, you probably wouldn't be able to see.
no wait,
like, you know.
if our brain didn't work like that, we'd see upside down.
Yeah, I guess.
Right, so like a little bit from them, I can tell you like the whole thing.
What's up?
Like I can write a little thing, but I can tell you all the things.
Maybe. Alright. Mia. What is let's say, what is the part of the eye that opens and closes based on how bright things are? What's it? Pupil? Cool. Elena, what's the colored part of our eye called?
Iris.
Yeah, iris. Awesome. And then we got this, Raphael. What kind of focuses that light? The lens. Awesome. And it hits the back. And what's the back of the eye called? Marcos. The retina. Awesome. And then in the retina, this light is changed into electricity, which is kind of cool. Like, again, we create electricity, and it travels along. This is electricity. So Carlota, what's it travel along?
Electricity, and it travels into the optic nerve.
This optic nerve. Awesome. All right, so that's a very quick model of the eye. Okay, and what's happening and why we're able to see things. Okay. Yeah, the cornea is that kind of the protection out here, right?
Wow.
So that provides that cornea. And what it allows us to focus too on the different items. So that lens in there focuses the light, but the cornea we're able to see things. Yeah, what's up?
I can go that this quick.
You'll have time. We made our map. So now we're going to figure out how light interacts with a lens. So another part of your book, I would think on a new page, because you're going to need, unless you have at least if you have less than half a page, go to a new page and then write how does light interact with a lens. because we have this idea now, the lens focusing the line. So we're going to want to do a little bit of investigation. Alright, so you're going to be in groups. The four of you will work together. 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 And the three of you will work together. And let me show you what you're going to do. Each group will have a flashlight, one flashlight, and one magnifying glass. Okay, and your job is to first have the flashlight up and have it on your notepad, notebook. You have to figure out at some point where you're going to stop. And wherever you stop, that's where you're going to outline the flashlights. You're going to have to do that in everybody's notebook. Okay? Where you have this distance, and then you keep it there. All right?
But
so
outline here.
the brightest part.
Here.
The brightest part. So you're going to want to outline the brightest part here. It does have two lights in it, so it gets a little bit weird, but that's fine. All right. Once you do that, you're going to keep it at the same height, and then you're going to start putting the lens, this magnifying glass, into the light to see what happens. All right. You can put it up and down, but at some point you're going to want it halfway through, and then again you're going to circle the light. Okay. So in the same spot. So if it's here, I do my circle. And then I don't move the flashlight at all. I put the lens in, and then I draw again the outline of the flashlight. Okay. Okay? All right. Yes, ma'am. Everybody's notebook. Everybody should do this. Okay. All right. So again, kind of move around so you can work with your. Yeah, I mean, I would like
Mira, si tú tienes el lens, que así. A dos lentes.
Does everybody have two?
Ah, aquí. Sí,
I mean, just outline the best you can. So again, remember. So first you're going to want to get rid of the lens. You want to draw the circle somewhere. You should do this in everybody's notebook. Everybody's notebook.
O es que se sal medio menos a mí me toca a mí. Pero ahora necesitamos no.
About 5 more minutes. Can you make sure everybody gets a chance?
Voy yo. Lo voy a borrar.
I mean, it's up to you. But you just shouldn't change the distance. Just keep the distance the same.
Bueno, ahora con administración.
Another 5 minutes.
Y ahora es más grande. ¿Te parece tu familia?
And can we draw the circle again? We have 2 circles. And then when the magnifying glass goes in, what happens? What happens when the magnifying You always have 2 circles in each notebook. Where's the second circle? So what happens when you put those in?
It goes like over and over. And it makes more circular. Es más
Yo hasta clonar. Yo probé la clon.
Él tiene un borrador, huele a tabaco.
Yo me sé el de I can't read the same voice. Es el $1,000,000 baby. Yo me sé el Fortnite.
A ver, mándame el borrador. Quiero ver el de $1,000,000 baby.
Lo puedo cantar, pero no lo voy a hablar.
When it's like this, they are so close. It's like so potent. It's like over, and then it's circular.
Why?
Because the reflection of the lens make it like a red.
Pero no lo voy a hacer.
Hi! Ending your investigation, getting back to your
Es que
desk.
yo ya no sé, espera, mira, yo ya no sé bastante porque me mandaron. Ay, sí, ya.
Ending it and getting back to our desk in 5,
Yo tengo
4,
arroba
3, 2, 1, and oh. That's not good.
Chico.
Alright, when we're ready, we'll start break. Actually, I should probably just start the time. Where are you supposed to be during the break? Out there in the grass. Should you be going anywhere else? No? Okay. Okay, awesome.
These are so good.
Oh, doggy shorts. Okay, so with your partner, talk about these two things. What happens when the magnifying glass is placed between the flashlight and the page, and how does the magnifying glass and flashlight model compare? Are you just getting in from the break? Okay. Compare to light entering the lens of the eye. So how do those two things compare? So talk to your partner about those two questions. Starting now, please. Let's go.
It is more circular when there is a magnifying glass. Which is something interesting.
So we have to do it quick.
It compares
Do you understand?
the length of the smaller.
Me enseñó que si se contacta de eso es más.
Why did he get hurt?
Lucy, era demasiado pico.
Should people get hurt?
Es mejor con el suelo.
Take you to the nurse? Alright, 3, 2. Hold on a second. Hold on, we do your thing. 1, hold on. Carlota, what happens when the magnifying glass is put there?
When you put the magnifying glass, it's like a smaller point and it's brighter.
Okay, it's smaller, it's more focused and brighter. How is this the same, Jose, as our eyes?
Because it's like this is the light, and when we put light down.
What's that?
Magnifying glass is like smaller and it's like more light, but in a smaller scale.
Okay, and how does that compare to our eyes? What is what? What is the magnifying glass in our eye? The lens, right? Okay, so similar things are happening here. So our lens does the same as that magnifying glass. It kind of takes that light and focuses and puts it back there. All right. So, what have we figured out at this point about light transmitting through the lens of the eye? So go ahead and summarize what we've talked about. How does light go into the eye and transmit through our brain so that we can see something? Talk to your partner about that. I guess, Lucia, you can talk with Elaine. Well, what's the whole process?
Se va a los enseña al rey y el rey hace ver la cosa. Hola, Paul.
All right, 5, 4, 3, 2, 1, 0. Miguel. Miguel, I got a question for you. When we think about light going through this transparent magnifying glass, does the light keep going in the same direction? Does it change a little bit? It goes in the same direction? What do you think, Max?
Go like this, like
But like that, when that light goes through the magnifying glass, is it the same or is there a change?
they are changing.
There's a change, right? And so some of that light that's on the outside, what does it do?
Making more shape.
Which that means that that light is going through and what? Changing direction. Okay? So we call that refraction when light changes direction. Okay, so when light travels through transparent material, it definitely changes direction. Okay? Yep.
And so like when we have it like this, it's going like this, suppose. And when we have the magnifying, it goes like there, but it's changing.
It's like this, right? And then it goes through the magnifying glass, and what happens? It kind of changes.
Mr. Light, it's like in the eye, like the clear part of the eye. Mr. Light, that is called the pupil.
The lens or what?
Yes,
Behind?
the lens. Mr. Light,
So that lens is behind, so it goes through the pupil, and then that lens focuses it.
It changed the direction.
Yeah, it changes the direction. So you can see it. It's here and it shoots down there. Okay.
Mr. Light, people are blind because the reflect doesn't get their brain.
Or they could have a problem with their optic nerve. There could be a brain problem. Yeah, who knows? Some people become blind because they got cataracts in their eyes.
And
that
why
block
do
the
like
light.
some people see borroso and they need glasses?
That's a good question.
Because the lens is blinking.
Okay, so now we have to be able to make a conclusion about how we see. All right. So what is the first step? What is the first step, Elena Valencia, when it comes to how we see? What first has to happen?
You need to bounce in an object.
Off an object and where? Into our eye. Okay, cool. When it goes through the eye, what happens, Rafa? When it goes through the eye, what's the first thing that happens? You don't remember? Yeah, Marcos.
It goes into our cornea.
Yeah, it passes through the cornea, the pupil,
The lens.
and then what? And then it bounces off the retina. Where does it go, Rafa? And then the retina. Okay, the retina. What happens at the retina, Max?
It like transmits to the optic nerve.
Okay, but what? What does it transmit? Remember, it's a beam of light until it gets to the optic nerve. What is it?
The electricity.
It's electricity, so it's changed. So they change this light to electricity. I mean, that's pretty amazing if you think about it. After it goes through this, what happens? It goes to the optic nerve. And then what happens in the brain, Martina? Oh.
You see the object that.
Okay, it processes it. Okay, it takes that signal. Remember, it's
And it
upside
turns it
down.
around.
Yeah, it turns it around, flips it over. Yes, ma'am?
Is that it, like when it turns in your brain, like because you see the object like turn around, but the brain can change it that.
It can. That's why a lot of times you'll miss-see stuff. Because again, if you think about it, your brain is just encased in like it's dark in there. Right? It's in a box. And the light gets through there and it goes through your eyes, and then your brain has to figure out what's going on. So that's why sometimes we miss-see stuff. It's because we don't really understand what we're seeing. Our brain is making a best guess as to what's going on. It's a fascinating thing. All right.
And it's like.
Take a moment, anchor your learning. We're getting there. These are not yours.
This is the last.
This is not yours.
This is this.
These are not yours.
Answer.
You should be anchoring your learning right now. This is not yours.
What do you say when you do?
This is not yours too.
No?
No. don't want to know. Because we're gonna leave it here. It's not. Magnifying glass.
Is this going to be in a school?
It's already there. It's always there. Monday. Well, these are not yours. You're going to print out sheets. Alright, at this point, I've given everybody some study sheets. So for the next 5 minutes, quiz each other. Let's go.
What are the options available? After the house, the team.
What are the basic building blocks?
Writers on writing about what is important about a piece or about a piece or connecting that necessary.
That's fine.
When it ratings
Quiz each other.
What is dimension?
Why do we zero
Why
out?
is more important than
What is the first step? Yes. What's the second? After we observe it, notice and more All right, less than a minute. Your magnifying glass?
Why are some people like
Why are some people like what? Why are some people like what? Lucia, why are some people like what? Like their eyes move? What's that? So I want you having to print them out. All right, getting your mini thing ready? You will lead in 3, 2, 1, 0. Make sure you have your mini thing paper ready. Please leave this on your desk. Please leave these papers on your desk as you leave. The only thing you're turning in today is your mini thing. Remember which turning tray you use. It all depends on your number. 1 through 6, 7 through 12, 13 through 18, and over 18. What's up? You're welcome. Voila. Remember, put your name on stuff, put your number. You don't want to waste your lunchtime practicing that. Sure no. All right. Define model as a noun. Define the model. Person, place, or thing. So the term model, that's how we kick this session off. We define it as a noun and as a verb. So what is the noun definition? Huh? Whatever you want to put. You can put any answer you want, as long as it's an answer and you thought about it. All right, so it's that representation we use to explain a phenomenon. A representation. A representation. Define model as a verb. Define model as a verb. A verb is an action, something to do. And the verb is the practice we do as scientists trying to figure out or make sense of the phenomenon. That's called modeling. That's the model. Great. What's that? I mean, that is a way, but you have to say this idea of trying to make sense of the phenomenon. That's the answer. No. Fill in the blanks. As the light passes through the blank, this is the same word, the blank causes the light to refract and focus to a point on the retina at the back of the eye. As the light passes through the blank causes the light to refract and focus to a point on the retina at the back of the eye. Both the same word. They're both the same word? And that word is lens.
What was the first one?
A representation that explains. All right, fill in the blank. Structures in the retina change the light signal to what type of signal? From a light signal to a what? And some people are probably trying to think, and the quieter we are, the more people can think. And that would be an electrical. So that changes to an electrical signal. Electrical. The electrical signal travels from the retina to the brain along the what? This is 2 words. Yes. Yeah, so you'll turn in your notebooks as well. Hold on a second. Yeah. Alright, and that's gonna travel along the optic nerve. Notebook goes in here.
¿Sabes quiénes son los?
What's your number? 14. Hello. Turn your notebooks, please. Thank you. Monday.